Hello, and welcome to the final lecture of the series on Bitcoin and cryptocurrencies, titled, perhaps appropriately enough, The Future of Bitcoin. And you'll see that I had a question mark there, and I put a question mark there for two reasons. One is that I'm not claiming to have any special insight into what the future of Bitcoin is going to be. I'm not going to make any predictions. You can think of this as possibilities for the future of Bitcoin, perhaps. But another more important reason that I wanted to have a question mark there is that a lot of these ideas for where Bitcoin is going to go and where cryptocurrency technologies are going to go and where blockchain technologies are going to go has come from entrepreneurs and developers and hobbyists, etc. And that's great. One of the consequences it's had is that this conversation has tended to be a little bit breadless at times of how blockchain technologies are going to revolutionize the world. And it's great to see that kind of enthusiasm. But as an academic researcher, one of my roles is to consider all of these proposals and to categorize them, analyze their pluses and minuses, and necessarily almost take a little bit of a skeptical view and so on. So I'll be doing that in this lecture as well. And that's the other reason I had the question mark in there. So we're going to be taking a look at these technologies, but also sort of analyzing them critically. Okay. So when we say the future of Bitcoin, that could be interpreted in a few different ways. One is thinking about how the Bitcoin system itself is going to change. Are there going to be major forks? And we've seen hard forks and soft forks before. We've seen what that would look like potentially. One could think about whether that's going to happen and what new features would go in if that were to happen. One could talk about efficiency and scalability improvements and so on. So modifications to the Bitcoin system itself. That's not quite the sort of thing that I'm interested in this lecture. In particular, what I mean when I say the future of Bitcoin is a set of ways in which blockchain technology can be used. It's been proposed to decentralize a variety of things: stocks, bonds, even property, whatever that means, we'll see. So in other words, people have looked at Bitcoin and went, we managed to decentralize currency. That actually worked. Let's decentralize everything. So it's this notion of decentralizing everything that we're going to drill pretty deep into. We're going to look at the technology, and we're also going to try to understand if that's a good idea for society, is it a good idea economically, etc. Okay, so what do I mean by this? More specifically, let's look at blockchain as a vehicle for decentralization. And I'm going to have a motivating example that I'm going to use to begin talking about this, but also come back to again and again in this lecture. It's going to be our running example. And this is something that's called smart property. Smart property is something that's been proposed, been around as an idea even before Bitcoin, but now it's taken on a much more concrete form. So let's look at what smart property is and how that would work and how that would be integrated with the Bitcoin blockchain. So here's the idea. Let's look at it through the example of a car and car ownership and selling a car and so on. So the first key idea is that the car is controlled by a cryptographic key. You have a digital key that opens your car, but further, there is some crypto that's built into it. How does that crypto work? The car has a public key that's hard-coded into it. And your key is going to have the corresponding private key corresponding to this public key. And therefore, perhaps when you approach the car, your key is going to automatically send a signed message to the car using, for example, Bluetooth. And the car, having the right public key, is able to recognize the authorized signature. And since only your specific key has the right private key embedded into it, nobody else will be able to fake that signature. And so you'll be able to approach and enter the car. So this is a foundational idea of smart property that we're going to take it to the next step, but this is where it starts. And this, I have to say, if you are going to make a digital car key, this is probably a really good way to do it. This is much better than a solution, for example, where the car has a secret number encoded into it, and your key also has a secret number, and your key simply sends that secret number to the car, which verifies if it got the right secret number. This is, of course, really insecure because it's subject to replay attacks and so on. But instead, an asymmetric cryptography-based solution is a good way for authorizing the owner to enter the car. So let's assume that we have a car that works in this fashion. What can we do with this? In particular, what does it mean to integrate this with the blockchain? Let me show you. So the next step in this design is that instead of having this public key hard-coded, what this car is going to do is it's going to dynamically update its public key based on what's going on in the blockchain. So what does that mean? When the car rolls out of the factory, it might have a particular transaction in the blockchain hard-coded into it, with the understanding that whoever owns the private key corresponding to the output address of that transaction basically controls the car. So in other words, the public key that the car uses to authorize the right owner corresponds to the public key that's the output address of this Bitcoin transaction. So you'd have to have some specific types of crypto to make it work. The signature scheme that the car is using should be the same as the signature scheme that Bitcoin uses and so on. But those are technical details that we can assume can be easily worked out. Right, and the car, you have to assume, is running a Bitcoin node and is constantly listening to the blockchain and using that to update its key. So how might that work? So this is a block in the blockchain. The next block rolls around, nothing of particular interest happens. And now we have one more block, but here there's something interesting. We have a transaction in the new block, which consists of transferring this particular transaction to a new address. And that new address, let's say, happens to be the public key of Bob. And so what will happen now is that the car will automatically update its public key upon noticing this transaction to be this new public key. And whoever has the private key corresponding to this public key will now be able to send the appropriate authorized signed message to the car in order to activate it. And that's going to be Bob now. So Bob's key now activates the car, and in this universe, there's no distinction between ownership of the car and the technical ability to open the car or activate the car by sending the right signature. So if we make that assumption, this Bitcoin transaction actually constitutes a change in ownership of the car. So that sounds pretty crazy, but now we're actually going to take it to the next level of technical sophistication. What we're going to do is, it's not enough to just have a way to transfer ownership of the car. For this to be meaningful in the real world, you have to have something that represents what a sale of the car might look like, sale of the used car from Alice to Bob. So what's necessary there? Not merely transfer of ownership of the car, but also transfer of payment from Bob to Alice. Right, but here is the key technical problem. Even if we assume that Alice and Bob managed to get to the same physical place at the same time, which in the car example is natural, but of course we might want to use this technology for other things like selling something over the internet. But let's not even get to that level of complexity. Even if Alice and Bob are in the same place over the same time, these ownership transfers or transfers of payments are things that are happening purely in the blockchain. Right, with no physical record on real paper or their actual signatures or anything like that. But one of them has to go first. If Alice transfers her car ownership to Bob, Bob might claim that's the end of the transaction and walk away without making the payment. So how will Alice prove to somebody, if she, say, wants to sue Bob, that Bob didn't hold up his end of the transaction? That seems like a problem. So we actually want to find a technological solution to this. So to solve this problem, of Alice and Bob being able to pay each other, but with neither of them being able to quit the transaction once the other one has done their half of the transaction, here's the technical solution that we can use. We're going to create a single Bitcoin transaction that combines Bob's payment to Alice with Alice's ownership transfer to Bob. And recall that this is a technique that we've used before. We've used it before in CoinJoin to create a single transaction that combines different parties' funds together to get it out in a different order. And we're using the same technique here. Now, this transaction has two inputs and two outputs. The first input and the first output corresponds to what the car understands to be representations of ownership of the car. But the second input and the second output correspond to the Bitcoin payment that Bob is making to Alice in exchange for the car. Now, to be sure, this input and this output will also correspond to actual Bitcoin value, but it will be minuscule Bitcoin value, probably a Satoshi, probably something very little, so it doesn't really matter. The only financial aspect of this transaction that matters is this input and this output that will correspond to the car payment. So as we saw in CoinJoin, you can create a transaction like this, and both parties can separately put their signature on it. So that's exactly what Alice and Bob will do. It no longer matters if they're in the same physical place or not. One of them will construct the transaction, sign it, send it to the other, and the other party will not be able to change any of the parameters of the transaction without violating the first party's signature. And so the only option that the other party has is either to quit the transaction, in which case no transfer has happened, either of ownership or of payment, or to put their own signature on the transaction and to broadcast it to the blockchain. And once it gets confirmed to the blockchain, when it has 6 transactions or whatever number that the car is looking for in order to signal a transfer of ownership, both of these will happen simultaneously. The car will switch owners, at least in the sense of who can control activation of the car, as well as money will switch hands. So we've accomplished something remarkable here, and this has some far-reaching consequences. And we're going to keep coming back to this example and understand this in better detail and talk about the different aspects of what we've seen. But let's start with something basic. So this is a technological way of representing ownership and transferring ownership. But what is the real-world analog exactly that it replaced? And how does this constitute a form of decentralization? Now, if you think about, for a real car, as things happen now, what constitutes ownership? It's clearly the title document. So we've gone from this world where the title document represents ownership. And let's be clear, this is a centralized form of ownership. What does that mean? The title document only has meaning to the extent that the DMV recognizes it. And to really drive home that point, when you sell a car, it's not enough to physically transfer this document to somebody else. One of you has to actually go and register that with the DMV. So there has to be a record of this in the centralized database. That's what it means for a car to change hands. So it's that inherently centralized system controlled by the state. And so we've taken the state out of that whole equation, and we've made it a purely technological process of what it means for a car to have a certain owner. And furthermore, we've done this pretty cool thing, which is to inherently couple the transfer of ownership of the car and the transfer of the payment. And all this is a completely decentralized process in that there is no intermediary anymore. So we've achieved decentralization in the sense of disintermediation. This is one of the types or levels of decentralization that we're going to see in this lecture, and there are going to be several more. So this is the first of many examples that we'll see in this lecture that allows us to use blockchain technologies to decentralize one of any number, any variety of different types of real-world analogs. And we'll achieve different types of decentralization. But 2 technical features that are going to be common to most or all of these examples are what are called representation and atomicity. And we're going to keep coming back to representation and atomicity. What are these? So representation is the question of how do you encode some sort of complex transaction from the real world into something that can be understood in the blockchain. In the example that we saw, the way that we did this is we took the idea of a public key that the car uses in order to look for the right signature to authorize the owner. And we simply represented that public key as a Bitcoin address. So we sort of used this hack, this equivalence, to solve the problem of representation. Atomicity is the other technical concept, which is how do you couple the different sides of a transaction so that they all have to happen together or none of them at all. Atomicity is an important security feature. It's not the only security feature. We're going to see some others, and this sort of thing can happen without atomicity. But it's a particularly important one. And in general, when we talk about a particular way to use blockchain technologies for decentralization, it's not really going to be viable unless it supports some form of atomicity. All right, so let's put these questions here that we're going to use to frame the rest of the lecture. One obvious thing we can ask is, what else can we decentralize this way? And we can ask, can this be done using the Bitcoin blockchain itself, or does it require an alternative blockchain? And we can talk about what are those other alternatives to atomicity that I alluded to in the previous slide. And finally, something that interests me a lot is it actually a good idea to do commerce like this? What problems does it solve compared to the real world? Does it introduce any new problems? Is it good for society? Is it going to be feasible in a business sense? So these are all questions that I'd like to take up.